Welcome back to Physics 30. This is Unit 1D, Part 2 of the Speed and Velocity section. It corresponds to pages 62 to 70 of your duotang. And in this one we'll be looking at average velocity again, recognizing situations in which we differentiate between speed and velocity, calculate speed and velocity, look at tables, graphs, etc. Look at displacement versus time, position versus time graphs, analyze position time graphs and displacement versus time graphs to determine average speed and average velocity. And solve problems involved concerning speed and velocity. So what type of motion is indicated by a distance time graph that isn't a straight line? In this case we're looking at non-uniform motion. So we're not going at a constant speed or velocity, we are in fact changing. Okay. So if we have a graph which illustrates some real-life situation and it's an average speed scenario in which we're speeding up, slowing down, not moving at uniform speed, could look something like this. It could be a curve indicating acceleration. If we're looking at, okay, on average, what's happening between this time and this time? So you simply locate those 2 points on the curve, connect the 2 points with a dotted line, and calculate the slope. So time 1, displacement 1, time 2, displacement 2, so d2 minus d1 over t2 minus t1. That's how you would do that. Okay, if we have non-graphical examples though, like something like this, a circus van moves 50 kilometers east in 1 hour, 40 kilometers west in another hour, 30 kilometers west in a half hour. Calculate the average speed. So of course we're doing different movements, we're changing direction here. Average speed is simply going to be figuring out the total distance over the total time. So here we have total distance 50 and 40 and 30. So we did a total movement of 120 kilometers. We're not concerned about direction where speed is concerned. We're just simply looking at total steps and total time. Total time, 1 hour, half hour, so 2.5 hours. So V is equal to D over T. Total distance, total time, 48 kilometers per hour. So there's my van there, and I assumed it had a bear or something. If you look at average velocity now, so velocity is this now. It is direction dependent. So we have to kind of draw a vector diagram here, or just sketch it to visualize it. So the movements were 50 east, 40 west, 30 west. So 50 east, 40 west, 30 west. So I started movement here, did boom, 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 ended here. So once again, this is a vector quantity. We're really looking at the resultant vector. So you can see I've done a total of 70 kilometers west, 50 east, so the resultant displacement is only 20 kilometers west. So after doing all this movement, what would it have been like if I had just started here and moved in this direction? That's really what we're figuring out here in terms of average velocity. So again, the total time, 1 hour and a half hour. And I get 8 kilometers per hour west. So the circus van doing these movements is the same thing as if the circus van had started here and went a slow movement of 8 kilometers per hour west. That's really what we're doing when we figure out average velocity there. Seeing what would be equivalent if I had just went from start to finish. Okay. Looking over here, a delivery van parked 200 meters east of a police car moves to a position that's 600 meters east of a police car, and I assume that the delivery van there had a tiger or something. That's why it's being sneaky and moving away. So very similar to the previous one, we're looking for what is the average velocity. First in meters per second, then in kilometers per hour. If we recall in the previous booklet, we looked at a shortcut as to how to go from meters per second to kilometers per hour, multiply by 3.6, or vice versa. If I'm going from kilometers per hour to meters per second, divide by 3.6. So the total movement From a position of 200 to a position of 600, that is 400 meters east. That's the difference. That's the change in displacement from start to finish. This all happens in 18 seconds. So quite easily enough here, V is equal to D over T, change in displacement over change in time. 400 divided by 18, 22.2 meters per second east. And of course, changing that into kilometers per hour, it's kind of a speed we're more familiar with using in everyday life. Almost 80 kilometers per hour east, just short, 79.9. Okay, another one here. Hiker walks 5 kilometers east, then 8 kilometers west during a 3-hour period. Determine the hiker's velocity. So again, starting here, 5 kilometers east, turning around going 8 kilometers west. So from start to finish, because velocity needs displacement, and think of displacement as your resultant vector. 5, 8, so you can see that that is 3, this section here, 8 minus 5 is 3 kilometers west. The time period is, let's see here, that's all 3 hours. So 3.0 kilometers per hour west over 3 hours, so you can see that's 1 kilometers per hour west. But average speed, looking at all the steps you have taken, 5 kilometers and 8 kilometers gives me 13 kilometers over that same 3-hour period. So to do that same movement, 4.3 kilometers per hour. Okay. Last one here before we move on to part 2 of the video. A driver travels by car 100 kilometers per hour east during a 1-hour period. And then he drives 2 hours at 82 kilometers per hour west. Determine the guy's resultant displacement, then resultant velocity. This is a little more tricky because we're not given displacements, we're given velocities here. So what we have to do first, V equals D over T, times each side by T, we get that. We need to find out how far this person went during these time periods. And here it's quite easily enough. It's 1 hour going 100 kilometers per hour. So you can see that you must have gone 100 kilometers east and then turning around, and then for 2 hours going at 82 kilometers per hour west. So that turns out to be 164 kilometers per hour. So it's tricky. You have to find out the displacements first. So started here, went 100 kilometers, turned around, went 164 kilometers. So from start to finish, the person actually went 64 kilometers per hour west. So then it becomes a question like on the previous page. It's just this little preamble at the start because we were given velocities. Average velocity, once we know displacement, of course it's a 1-hour period and a 2-hour period, so it's a total time of 3 hours. 64 kilometers west divided by 3 hours, so that works out to be 21.3 kilometers per hour west. Then the next one, okay, what's the distance traveled? Well, here we're not concerned about direction, we're just concerned about every single step we took. 100 kilometers and another 164 kilometers. It's a total of 264 kilometers. And then for average speed, of course, you take that total distance divided by 3.0 hours, 88 kilometers per hour. And you should be ready to do the first part of the quiz here. But I'm going to stop it here, and we're going to do part 2 in the next segment here. See you soon.